Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss another topic from the same chapter which we have discussed in the yesterday's session, that is biomolecule. Today we are going to discuss the osazone formation. In the yesterday's class we have discussed about the cyclic structure of glucose. The osazone formation is also related to the glucose molecule only. Let me just write down the titles first of all. So we are discussing another chapter from the same chapter, another topic from the same chapter, biomolecules. The title of the topic is osazone formation. O-S-A-Z-O-N-E, osazone formation. Osazone formation. So what is this osazone? So osazone is nothing but the type of addition compound produced when aldose sugar react with phenylhydrazine. Okay, so that is simply the definition of osazone is. Okay, aldose sugar means the sugars or carbohydrate which have aldehydic functional group, which have CHO functional group in them. Such a type of sugars are called as aldose sugar. When these aldose sugar react with phenylhydrazine, so phenylhydrazine, when they react with phenylhydrazine is nothing but C6H5NH2. I am going to explain the mechanism as well as the reaction in detail. Right now I am just only writing, and we are getting the osazone. Okay, so this reaction we are going to discuss in today's class. So first of all, let us see this reaction for the let us see this reaction for the glucose molecule. Okay, yes, so structure of glucose we have already discussed. Osazone formation reaction I am going to explain with the open structure of the glucose, right? I have told you the trick to write down the structure of the glucose, aldohexose sugar, already in the yesterday's class, so I am writing it very fast. So glucose is the 6 carbon compound containing aldehydic functional group, therefore it is aldohexose, right? So in glucose, as we know, this is your aldehydic functional group, the C1. Then next 5 carbon atoms I will write down in a row like this, OH and OH. So wherever OH is there, you have to write down the H on the left hand side. So it will be H, OH, H and H. So this is the structure of glucose, right? This is the structure of D-glucose. Here D stands for the OH on the anomeric carbon atom is on the right hand side, right? D-glucose, which is the aldohexose, right? So this aldohexose glucose can react with the phenylhydrazine molecule. Phenylhydrazine, 3 molecules of phenylhydrazine are required here. Okay, why 3 are required? I'll explain later on with the help of mechanism. C6H5NH2, this is nothing but your phenylhydrazine. Okay, and when we are treating your glucose with it, we are getting the aldohexose. Let us see what is the structure of that aldohexose. So in that aldohexose, listen, so this is your carbon number 1. I'll just shift it above. So this is attached to hydrogen, double bond N, NH, C6H5. Then this is your second carbon, which is also attached to N, NH, C6H5. Then rest of the other carbon atoms are as it is. Rest of the 4 carbon atoms, they are not having any change in them. CH2OH, this is OH, OH and H. So this one will be OH, H and H, right? So this is the addition product which is called as osazone. Okay, yes, osazone is the main product. Apart from that, it also is byproduct like C6H5NH2. C6H5NH2 is nothing but aniline, which is one of the byproduct produced. Then ammonia and water. Okay, so this is the reaction of osazone formation of glucose. So what type of question they can ask on the basis of this reaction? They can ask the number of phenylhydrazine molecule required for the oxygen formation for one molecule of D-glucose. So such a type of one question was asked in past year JEE mains exam question paper. So the question is like this: glucose molecule needs X number of molecules of phenyl hydrazine to form the oxazole. The value of X is 2314. So 3 is the correct answer, right? Okay, now this was about the general reaction. Now we are going to discuss the mechanism for this oxazole formation, right? Now to explain the mechanism formation, as it requires writing the glucose molecule for multiple times, I will not write down the glucose molecule completely, just like I have written here. So what I am going to do, I am going to, instead of writing down CHOH for multiple time, I will just write down CHOH and then like this. Okay, so let me just explain the mechanism to you. Because the reaction takes place on only the first. Yes, I hope you have taken a screenshot of this page before starting the mechanism. Okay, now let us see the mechanism. I will not write down the glucose molecule completely. I will just write it down like this. As only first two carbon atoms are taking part in the reaction, I am going to focus on that part only. Okay, so this is the CHO group and this is the CHOH group. Rest of all I am writing down like this. Okay, I will just mention it here to save the time. Here this means remaining structure. Okay, I am not writing it here, okay, to save the time. Okay, I hope you can understand. So this is the remaining structure which is not even taking part in the reaction, so that's why I am not writing it. Okay, so what happened, first of all, in the first case, this reacts with the first molecule of phenyl hydrazine. Do you remember in the aldehyde, ketones and carboxylic acid chapter, we have seen this reaction. When we are treating aldehyde, this is your aldehyde, right? RCHO. When aldehyde is treated with the phenyl hydrazine is C6H5 attached to C6H5 is nothing but the benzene ring, that is phenyl ring. Okay, this is your phenyl ring attached to NH2, right? This is your C6H5NH2. So instead of writing it like this, I will just write it like this: NH2 first, that is H2N, then NH, then C6H5, right? So I will write it like this so that I can show the loss of water molecule. So water molecule is lost from this, okay, like this, and we are getting yes, so after loss of water molecule we are getting R C H double bond N NH C6H5, right, which is nothing but the hydrazone, right, which is nothing but the hydrazone. Okay, yes, so this reaction, this is the addition, this is the nucleophilic addition reaction which we have already discussed, studied in the aldehyde, ketones and carboxylic acid chapter. Same kind of reaction takes place here for glucose. Glucose is nothing but the aldehyde only, right, aldohexone. Therefore it also shows the same reaction, right? So I will write down here, then C6H5 NH2, that is your phenyl hydrazine, I will write down in this way: NH2NH C6H5, right, NH2NH C6H5, which is nothing but your phenyl hydrazine, right, which is nothing but your phenyl hydrazine. Addition reaction will take place, there is a loss of water molecule, right? So water molecule will be lost like this, okay, and so I will write down here minus H2O, dehydration takes place, minus H2O stands for water molecule is lost. Okay, after loss of water molecule, what we are getting? So it will be C double bond C H remains as it is, so it will be N NH C6H5, right? So this kind of addition product will be obtained. Rest of the structure as it is. Okay, so this OH I am going to write down like this, just expanding, because it is going to further take part in the reaction, right? Okay, so this kind of addition product we are getting. So then further it undergoes the tautomerization, right? Whatever it is produced here, it undergoes tautomerization. Okay, so let me write down here. Okay, it undergoes tautomerization. Tautomerization is kind of isomerization in which the molecule undergoes rearrangement within itself, right? So what happens here? This bond gets shifted on the nitrogen, and this bond gets shifted in between the two carbon atoms, right? Due to which what will happen? This hydrogen will be attached to this nitrogen, right? So within the same molecule, hydrogen will be shifted from one position to another. So I will write down on the arrow plus minus H plus. Proton is transferred from one position to the other. So I have written plus minus H plus. Okay. Yes. So let me just write down what we are getting after this. So after loss of or shifting transfer of proton from one place to the other. So here this hydrogen of carbon is as it is. Double bond converted to single. Nitrogen attached to hydrogen, right? This nitrogen will be attached to hydrogen. This first nitrogen already has that hydrogen, so that also I will write down like this, and this is the C6H5, right? Only one nitrogen was having hydrogen here, now both of them will have hydrogen. Now here previously there was a single bond, now it will be converted to a double bond, right? Yes, then this is a double bond attached to O and H, and this is the rest of the structure, right? So this is the tautomer which is obtained after the reaction. Now again there will be some further transfer. Just this part I will just write down like this. Means remaining structure. So that I can show the reaction here. So what happens after this? Again the transfer of hydrogen takes place. How? What happens? This bond gets shifted here, then this hydrogen will be taken by this nitrogen, and this bond gets shifted here. Okay, yes. So after this what happens? This is going to detach from the molecule, right? What is going to detach? Can you see? C6H5NH2, right? C6H5NH2 will be lost. Okay, so that I am going to write down on the arrow, right? Which is nothing but one of the byproduct, minus C6H5NH2, which I have written already in the general reaction. C6H5NH2 is one of the byproduct, which is nothing but your aniline molecule, right? After loss of aniline molecule, let us see what we are getting. So again this carbon will be attached to hydrogen as it is, then here it will be a double bond, here it will be NH, right? Here it will be NH. C6H5 is lost from the molecule, then this will be single bond, this will be carbon double bond, and this will be further structure, right? So after this we have obtained one more CO group in this, right? After this we have obtained one more CO group in this. Okay, so let us write down the further reaction. I'll just increase this arrow so that it will not look isolated. Yes, okay, so this is the product obtained. Now this further again reacts with the another molecule of C6H5NHNH2. Okay, let us see that. Okay, so first molecule of C6H5NHNH2 has been used. Where? Here. First molecule has been used here. Now we are going to use the next molecule of C6H5NHNH2. So how we are going to use that next molecule? So further it reacts with another molecule of phenylhydrazine C6H5 NH2. Okay, now this NH2 I will write down like this. Okay, the another molecule of phenylhydrazine. So what happens here? This another molecule of C6H5NH2, there will be loss of water molecule from this. Okay, there will be loss of ammonia molecule from this. How ammonia molecule is lost? Let us see. First of all, let us see the reaction on this and then on this. Okay, so one by one we will see. So what happens here? There is a loss of ammonia molecule. How ammonia molecule is lost? So NH2 from this and hydrogen from this. Okay, NH2 from this and hydrogen from this is lost in the form of NH3. So there is a loss of ammonia. After loss of ammonia, let us see what we are getting. Carbon attached to hydrogen, double bond N, then NH C6H5, right? This part will be attached further, NH C6H5. Do you understand? So what is lost here? NH2 from this and hydrogen from this. That means the NH3 ammonia molecule has been lost. So this phenylhydrazine molecule is used for the loss of ammonia molecule, right? And hydrogen from this and NH2 from this. So this is how ammonia molecule has been lost. After loss of ammonia molecule, C double bond N remains as it is, like this. Then this NHPH, NHC6H5 will be attached further, right? Okay, then remaining structure as it is, C double bond O and remaining structure, right? Again, we have one more site for the attack of phenylhydrazine. So further reaction will take place. So one more molecule of C6H5NH2 I will use. Now I will write down this as H2N NH C6H5. That is phenylhydrazine only. So here there will be loss of water molecule, just like in the first step I have shown. Exactly this step. Okay, exactly this step will take place. So how the reaction is going to take place here? So there will be loss of water molecule. How? Like this. Okay, there will be a loss of water molecule minus H2O. After loss of molecule, we will get the final product. Okay, yes, so let me write down the final product then. So it will be C attached to H, double bond N, NHC6H5. Okay, this is the first part. The next C also converted to double bond N, NHC6H5. Then remaining structure as it is. So I am going to write down the remaining structure now. Next are the 4 carbon atoms. Fourth one is CH2OH. There is no change in the remaining 4 carbon atom. They will remain as it is. Okay, so this one will be OH, this one will be H, this one will be H. So this is the OSA zone of glucose. Okay, this is the OSA zone of D-glucose molecule, right? Now in this OSA zone molecules, if you observe its mechanism again carefully, what are the byproducts obtained? First byproduct is nothing but C6H5NH2. Next is water, and third one is ammonia, right? So we are getting these byproducts in the reaction. The 2 molecules of water, let me just remove the highlights. Yes, so what we are getting 2 molecules of water, one molecule of ammonia, and 1 molecule of aniline, right? So this is the mechanism of O-ozone formation. You can just take a screenshot of this mechanism first of all, and then I will explain it again. Just take a screenshot of this page. Okay, so let me just explain the mechanism part again. I hope you have taken the screenshot. Okay, so yes, in the general reaction you can see the for one molecule of glucose or any aldohexose, not only for glucose, for one molecule of aldohexose, 3 molecules of phenylhydrazine are required for oxazone formation. Now, by observing the product, we get confused that where is the third molecule of phenylhydrazine, right? You can see only two C6H5NH group here, but where is the third one? So that third one is in the form of a byproduct aniline. So how that byproduct aniline is generated, we are going to see with the help of mechanism. So in the mechanism you can see the first step is normal, simple, just like aldehyde, any aldehyde react with the phenylhydrazine, right? So what happens, there is a loss of water molecule and we will get a simple hydrazone formation here. But as that hydrazone is just next to the OH group, therefore further reaction takes place. So there is a loss of C6H5NH2 aniline molecule after tautomerization, and after that we are getting C double bond N here. So there are two centers now to react with the phenylhydrazine. One center is C double bond N and another is C double bond O. So first of all, let us see the reaction with the C double bond N center. So C double bond N is there, therefore there will not be loss of the water molecule, but there will be loss of ammonia molecule. NH3 will be lost and we are getting the similar kind of, just like we get the for aldehyde, exactly same product we are getting here. Then again we have CO. So that CO combines with the third molecule of phenylhydrazine, loss of water molecule takes place and we are getting the final product which is called as oxazone. In this oxazone you can see there are two C double bond N NHC6H5 groups. Rest of the structure is as it is. Rest of the structure of aldohexose will not change. Okay, so this is the mechanism of oxazone formation for glucose. Now, if in general I want to write down the mechanism or this for any aldohexose or aldose sugar, not only aldohexose, aldose sugar, I can write it down, right? So in general I will write down, just like glucose, all others also will react in the same manner. So I am going to write down that reaction now. So this is the general reaction for all aldose sugar. Okay, general reaction for aldose sugar, general reaction for oxazone formation, obviously aldose sugars. Okay, yes, let us see how to write down that reaction. So for all aldose sugar there will be C double bond O here, right? All aldoses will contain this. Then next part is CHOH, right? CHOH also takes part in the reaction. I'll write it down like this, CHOH. Okay, now these two things will be present in all aldoses. Then on the basis of whether it is pentose, hexose, heptose, what are the carbon numbers, the rest of the structure will be different, right? So the rest of the structure I will write down CHOH bracket N. N will be different for each and every aldose, right? N will be 2, N will be 3, N will be 4 and so on, right? So this is the aldose sugar, right? CH2H will be common in them, just the number of CHOH will be different. Okay, yes, but no matter whether it is aldohexose, aldopentose or aldoheptose, always 3 phenylhydrazine will be required. C6H5 NH2, always 3 phenylhydrazine molecules will be required for aldose sugar. Okay, if it is a ketose then different number will be required. Okay, then what will be the product for this reaction? So after this we are getting, so C6H5, and again this is also converted to the same N NH C6H5. Then rest of the structure remains unchanged. So again I will write down CHO is inside the bracket, here N and CH2OH. Right, this structure is not going to change. So this is how we are getting the O-Sajan formation. Byproducts will be same. So byproducts are plus one aniline molecule C6H5NH2 plus one ammonia molecule and two water molecules. Okay, so this is the general reaction for all types of aldose sugar, no matter how many carbon atoms are present in it. Okay, I hope it is clear to you. So today we are going to stop here for this particular chapter. In the next class, in tomorrow's class, we are going to discuss the next concept from the same chapter. Okay, that's all for today from my side. Before ending the class, let me just show you the DPP, daily practice problems. Yes, so I hope you can see the screen. So this is about daily practice problem DPP. This is a teacher's portal. Similarly, you can see your portal when you log into it. You can go to resources, then you can go to writing material. On this left hand side you can see, wherein you will be able to see all the DPPs, daily practice problem. You can just download it here, write down the solutions of all the questions in the DPP on a paper, and a paper or a notebook also you can use. Take a picture of that solution part and say, just upload it here. The image you are going to upload it here in the portal, in your portal. So teacher will be evaluating it and sending you the suggestions and corrections wherever required. Okay, so that was about the DPP, and I hope today's session was clear to you. You understood each and every concept which I discussed in today's session. If you have any questions, you can ask anytime in the next section also. So let us end the session. Thank you so much, students, for your precious time, and all the best to you, and take care. Bye.